Hey guys, welcome to Code Decode. In this video, we are going to look into a very common microservice component, that is API gateway, and the most misunderstood component also. In an enterprise level application, if you have a full-fledged Kubernetes containers applications deployed there, if you by any chance used ingress controller, service mesh, and API gateway, and if you have used API gateway for the backend communication, and by any case if you have used service mesh for the outside communication, any interviewer would know you have never worked upon API gateway in the practical life. So let's stick to the end of this video and see, do you really know when to use API gateway, when to use service mesh, when to use ingress controller, and do not mix and match both in a wrong architectural way. Outside communications always through the API gateway, inside communications always through the service mesh. We will see each and every aspect in this video and an end, and we'll see where you can go wrong in an interview, where interview can easily catch you that you don't have any practical implementation knowledge on API gateways. So let's get started. Let's first see how the API gateways are the entry point for your microservices. So remember, there is a client, be it the mobile client, be it the desktop application, be it your client partners, anything outside your Kubernetes world cluster or anything outside your VPN, anything on the public internet has to communicate with your internal Kubernetes container cluster or your VPN through API gateway. So API gateway is an entry point from the public world to your inside VPN. So what is an API gateway? An API gateway is a main gate to your city of microservices. Instead of letting visitors roam around inside your society, knock 20 different doors and then come to one door and say, okay, now this is the URL that I want for product service, this is the URL I want for the order service, this is for the user service. Rather than doing that, go to one door. That is the security check. The security guard will actually navigate you to the exact path where you will get your user service, where you will really get your order service, where you will get your payment service. So the gateway decides where to send the request, what security checks to run, and whether the change in the request or combine the data from multiple places before. Basically, the aggregation part is also done by API gateway for you. For example, if you have to find out the user details with their order details, then it is the task of an API gateway who can merge both the responses to you, create one DTO which has both order response and the user response, and merge it and give it to you. So aggregation and combining of multiple microservice data can also be done at the API gateway level. So you can think about it as a traffic controller who redirects you to the right path, a security guard who checks whether you are the right person to enter into the society or not, and a translator and aggregator who does all those protocol transformations, which I'm going to tell you in the next few minutes, like from REST to gRPC communications, all those for your microservices, and also aggregators. Hey guys, recently we have launched a course covering an end-to-end full-stack application using Angular as front-end and microservices and Spring Boot as the back-end. Also, we have used Cloud to deploy this application, and we have used CI/CD, that is Jenkins and Argo CD, for continuous integration and continuous deployment. The technologies that we have used is RESTful web services, Spring Boot and microservices for backend, Angular for frontend. GitHub we have used for version control system. Also, to make the code unit testable, we have used JUnits. We have used Sonar for code quality checks. Also, for containerization, we have used Docker and Kubernetes. And to deploy this whole application, we have used AWS and multiple services from AWS. Also, we have used SQL as well as NoSQL, that is MongoDB and SQL. On AWS, since for the SQL we have RDS, we have used those services, and Jenkins and Argo CD for CI/CD pipeline. Also, this is an architecture of the application that we have created where the front end is Angular and the back end is microservices. We have used ALB load balancers, ingress for routing and load balancing. And we have used SQL and MongoDB for SQL and NoSQL DB management with Eureka server and all those microservices counterparts. Now this is the CI/CD pipeline. This is the CI/CD flowchart for the application that we have created on local. So this is something, a flow when you create an application in local, push it to GitHub, create a Jenkins pipeline and do the CI/CD using Jenkins and Argo CD. And at the end, deploy the whole code at AWS EKS. Complete description of this course is covered in a very separate video. The link for that video is also given in the description bar below. And also the link to purchase that course from Udemy is also in the description bar below. So please go and check the description for all these links. Now a very important question that usually interviewers expect you to know is when to use API gateway. Is it really making sense of using the API gateway in your system, or the service mesh might have been used? ISTIO, that is a service mesh for you. And it does really make sense when the API gateway has to be the real entry point from your public domain to your 20 different microservices, so that your public domains, maybe the front-end application or the React application, should not have to remember 20 different URLs, one for each product service, order service, user service, payment service, and so on. Then it is better to get a unified edge, get it to one place, and then redirect from there. So with a gateway, you only know one URL, that is API gateway URL. And then internally, it is going to redirect to the exact location. You also manage your SSL certificates there. You also manage routing at one place. Also, you handle the authentication and authorization at one place. So if you can see here, authorization, authentication, all those things also can be handled at the API gateway level. Also, you can handle the mutual transport layer security between different microservices at one place. Also, you can have the proper firewall also to block the suspicious IPs and SQL injections and bots coming from the public world into your private VPN. Also, you can have multiple rate limitings. You have request size limits, course headers, request schema validations. All those rules applied at one place, that is API gateway. You can also aggregate data between the user service, order service, and product service into one D2 and give as a response completely as an aggregated one. And hence it is also called as backend for front end. So your front end, that is React application, give a call to your API gateway, which becomes the backend. But actually it is not the backend. Backend is actually your product service, order service. But BFF is the backend for your front end. So API gateway easily behaves as a backend for your front end. Also, that the protocol translation that I was talking about in the introduction part. Suppose you get a HTTP or REST endpoint call at your API gateway, but internally your user service and order service uses gRPC to communicate. Then this is the task of API gateway to translate this REST API into gRPC call, get the data, call the user services into the gRPC format, get the data, convert that into the REST response and give that as a HTTP response back to your client, which helps you to translate the protocol from HTTP to REST to gRPC, and vice versa as a response in the gRPC format as a GraphQL response to the HTTP or the REST response. Also, you can do the A/B testing on the API gateway, sending 20% to the new users and 80% to the old API users, so that you can do the proper A/B testing. You can do the canary release, blue-green releases, that is switching between different environments. Using the routing at the API gateway level, you can also do the circuit breaking, saying that order service is down, so I'm not going to give you any kind of response from the order service, and you can have a fallback mechanism that you can serve but you cannot order to the microservice. That circuit breaking logic and the fallback mechanism and resilience can also be applied at the API gateway level. And you can have the centralized observability and tracing at the API gateway level, that all the routings, before routing a particular URL, you add the trace parent or the micrometer tracing, so that one trace ID can go across multiple microservices and your logging and tracking becomes easier. So that was when you should use API gateway. Now there is a one beautiful situation where you should not use API gateway, and if you are saying that you have used API gateway in such scenario, interviewer will clearly understand that this is not an enterprise level situation where you should use it. For example, you have just the set of microservices in your own VPN. There is no front end calling to it. It's just the batch processing that is being done, and there is no public interfacing, then you don't need API gateway. Only and only if you have a VPN, your internal cluster, Kubernetes cluster, and no public domain calls, then don't go for API gateway. What do I mean by that? If there are only internal only communications, that is if all your service talks to each other inside a secure network like Kubernetes cluster or a virtual private cloud, and you already have a service discovery to find each other, you already have mutual transport layer security and the firewall being added by your cloud automatically, then API gateway is of no use. Easily anybody would understand that if you don't have any public interfacing, then adding the API gateway will just add an extra hop. It will also add a single point of failure, also will give you a maintenance overhead. And I would know that if all your microservices are within one VPN, no outside public domain or the internet communication, and still if you're using API gateway, then your architect might have already stopped you and you don't have any practical knowledge on API gateway. And still if you're using it, that means you're not an enterprise level application. So if your product service and order service are all in Kubernetes namespace, even your Angular is somehow deployed in the same Kubernetes cluster, no communication with the public domain or internet domain yet, and still you're using API gateway, you are doing something wrong. The second scenario is if you're a very small system, only 2-3 simple microservices, you don't have to remember 30 different URLs or 20 different URLs. Then your front end can directly give a call to user service and payment service. You don't have to add an extra hop for no reason. So it is just like hiring a full-time security guard for a single family house. So in this situation, API gateway is an overkill when you have a very small ecosystem. If you have a big ecosystem, big enterprise level application, API gateway sounds sensible. Otherwise, it is just an overkill. The third important point is if you have a service mesh already in place, then the service mesh internally handles your mutual transport layer security. It already handles your service discoveries. It already handles your load balancing, even the blue-green shifting also. For example, in our Udemy course, we have used one that is called as Kubernetes. And we have used ingress controller. Then in this scenario, Kubernetes already handles, the mesh already handles 80% of your logic that API gateway is doing. So only thing that you need is ingress controller to handle your incoming traffic and routing it. You in this scenario for sure do not need an API gateway. For example, if you have used Istio and you have already defined mutual transport layer securities with different services, and you have used the routing in your IOS auth also, then just adding this ingress controller will be enough. Using service cloud gateway is an overkill and you don't need it. So the thumb rule is use API gateway only if you need centralized security, routing, and you have a client facing feature. Very important point. If you're an e-commerce website, API gateway and service mesh becomes necessity. If all traffic is internal and secured, that you only have to run the batch process. No customer, no consumer, no app, no desktop website, nothing. Only a batch backend process. You don't need API gateway at any cost. You don't even need any client interfacing. You don't need API gateway. If your system is too small, using API gateway is an overkill. You have to manage one extra thing. Also, if you already have a service mesh that does 80% of the API gateway, and still you are using API gateway and not the ingress controller, then also it is an overkill to you. In some situations, I'll tell you an architecture where in an enterprise level application, you need all the three: the service mesh, the ingress controller, and the API gateway. But I'm going to discuss that in an architecture where that is also a necessity. So the decision checklist is if you have multiple clients who talks to many different microservices, use API gateway. If you don't have any client-side interfacing, public internet usage, don't use it. You want authentication, rate limiting, monitoring, logging all in one place, go for it. If you want to combine the aggregated data, you want to change HTTP to gRPC protocol and back gRPC response to HTTPS response, the REST API response, then use it. But if all your calls are internal, no client-side interfacing, no public domain calls on your internet VPN, you have latency sensitivity and you already are very secured with mutual transport layer securities and certificates, completely skip the API gateway. So use this API gateway only and only if you want to do all these things that I've shown you in this diagram. That is authentication, authorization, rate limiting, request validations, aggregation of multiple and transformation of response, conversion of your REST HTTPS request to gRPC request and back to that, then use API gateway, otherwise don't. Now a very common pitfall that if you would say this, I would know you have not used API gateway in an enterprise level application. If you say I have used a business logic in your API gateway, I would know you have a wrong architecture in your API gateway, because API gateways are not for business logic. It is only for authentication, authorization, logging, transformation, aggregation, but not for business logic handling. For example, if your product service give a response that your total order is less than 500 rupees, you should give a delivery charge. That logic should nowhere go inside your business logic in the API gateway. Then I would know you have a bad architecture of API gateway. The gateway should always be stateless routers, not a business brains. If the API gateway goes down, you don't want your core logic to go down with it. So keep your delivery charges, costing and management only to your payment service or your order service. Don't use that in your API gateway level. Also, if you have a service A and service B and no outside communication with any network, and still if you're using an API gateway as an extra hop and latency will be added, then you are doing it wrong. You are doing an anti-pattern. So internal calls should always go through a service mesh and never an API gateway that I've shown you here. If you can see here, this is my outside world. That is your mobile application, your browser applications, your different clients who works on the internet. This is the layer for them, that is API gateway. Either you can use a self-managed API gateway like API GEE, or you use self-hosted API gateway like Spring Cloud Gateway. But all the internal backend services should communicate using the service mesh like ISTIO. Also, if from your gateway, if by any chance in your understanding of the project says that your API gateway store any data to database, I would know you have done a wrong configuration of API gateway, because API gateway should be completely headless and stateless. It should never add any data or persist any data to database and become stateful, because it breaks the scalability. If I have 10 copies of same API gateway, how would I manage synchronization between different reads and writes of the databases? So that is why if by any case you have any logic written in the gateway to add the data to the database, you have a wrong API gateway configuration. Now last and a very important thing that 90% of us don't know. There is something called as edge and inside. Edge is this. This is called as edge. That is the entry point of your city of backend services. This is the edge where API gateway should be there. And the inside, it should be always the service mesh. So all your backend service should communicate through the service mesh. All your external clients should communicate your backend services with API gateway. So the edge, or what you call as north and south, should communicate with API gateway, while your east and west, that is your backend services internally, east-west traffic, should communicate through service mesh. If it is difficult to understand, I would totally understand. You have to let me know in the comment section to create a video on ISTIO, mTLS, that is mutual transport layer securities, and ingress controller separately. I'll create a very separate video on that. But this is understanding more around the API gateway level, when and where to use it. So that is why I'm not covering the service mesh and the ingress controller in that much depth. So the edge should always be the API gateway. API gateway is actually public front door. This is very important for you to understand. It is a public front door. If you have a VPN or if you have a Kubernetes cluster, all the public APIs hitting your service should have the front door with API gateway. But internally, user service and order service should not communicate with each other through API gateway. It should always be through the service mesh like ISTIO. So API gateway sits at the internet boundary, that is edge. This is the edge where it sits, at the boundary where your clients interact with you. And it is the first component to receive all the traffic from browsers, mobile apps and your client partners. And its basic responsibility is authentication, authorization, protections, rate limiting, routing, transformations, CORs, observability, logging, productionizings, handling canary, and all kinds of deployments, and all those things goes with them. And you can apply this API gateway as managed as well as self-hosted. So you can use API GE where you don't have to do anything. They will give you all the routing and all those things. You can also have your own self-hosted Spring Cloud gateway kind of thing, which runs in your own virtual machines. But you make sure that in your API gateway, you keep no business logic. You keep it headless, stateless. You have a fast decision and routing making mechanisms. And do not push any business logic into that API gateway. The second very important thing is the service mesh, that is east to west traffic control, that is the traffic control between different microservices, that is order service communicating to the payment, communicating to the user service. So what is a service mesh, ISTIO and kind of those things? These adds a network layer for east-west, that is service to service traffic. Whenever, if in any case, in an interview asks that what is north-west, what is north-south and east-west communication of an application, you would know that north-south is outside applications connecting with your inside backend microservices, while east-west communication is service talking to your internal service. So apps talking to each other through localhost, sidecar proxies doing the internal talking, all those things are actually handled by the service mesh. If it is too complicated, don't be stuck to this. Just understand that service mesh is used for your different internal microservice communication. Do not use order service communicating to API gateway communicating to user service. Rather use order service communication to mesh to user service. So internal communications goes through service mesh like ISTIO, and their responsibility is mutual transport layer communication security, service discovery, resilience, network policies, and all your logging telemetries. And how these pieces connect with each other, very high level flow. There is a client, there is an API gateway which is a public edge, then there is an ingress controller who is the load balancer, then there is a mesh who communicates, who is the one who help communication between different microservices A, B and C. Now gateway handles north-south, that is internet to cluster communication, while the mesh handles the east-west concerns, that is service to service communication. Though some teams do run mesh gateway if they don't need full API gateway features, also if you do the self-hosting gateway inside mesh so that they benefit from mutual transport layer communications and telemetries. But these are very rare and you should have a very strong reason why are you merging both of them. 99% of time, the good enterprise level application architecture should always have API gateway as the public face, and service mesh is an internal face which communicates between different microservices. Common pitfalls that you should not do: don't set the rate limit in both gateway and mesh. All the rate limiting should be at the gateway level. Business logic at the gateway is the common pitfall. Don't do that. Ensure that you add the trace parents and the span IDs to each end-to-end communications with this API gateway and ISTIO. Also be clear when the transport layer security has to be terminated and where mutual transport layer security begins. The mutual transport layer security is when each front end as well as back end has to make sure that they both validate themselves as they are valid people. Now, just no-brainer summary. If you're using API gateway, use it as a public edge. If you can see, this is the public edge. Use it for multiple things like rate limiting, authorization, authentication, request, transformation, aggregation, routing, conversion of different protocols from REST to gRPC and back, and logging and monitoring. Use service mesh only and only for your internal security, giving the mutual transport layer security handling, discoveries, retries, automatic reads, canary deployments, blue-green deployments, telemetry handling, that is logging, tracing, micrometer tracing, and those. Use both when you have an external client and a complete microservice estate, that is 20-30 microservices internally being communicating with each other, that benefits from internal resilience. Use mesh only ingress if you just need a secure entry into your mesh managed internal world. So you can use API gateway only if you have only 2-3 microservices. They can communicate without API gateway also. If you have a very big enterprise level application like Amazon, where there's a lot of external clients and a lot of microservices also inside, then use an architecture like this, where your outside world communicates to API gateway, your inside world communicates with each other through service mesh like ISTIO. That is all on this API gateway level, when and where to use it. 90% of us don't know where actually API gateway is used and where it is not. So let me know in the comment section if you want to know more about ISTIO or the service mesh and the ingress controller. Thank you.